So we just have one piece to look at here, and in some sense, this is the most interesting part of this example because this is the part that's back pressure aware. This is where the back pressure really comes out in full force. And so we're going to take a look at how we structure the client code, which sends the messages back and forth and is aware of back pressure. So there's three main parts to the client besides the driver program. The first is the client beans class. And that's the part that returns a mono to an RSocket requester that's connected to the server. And as you can see, there's a chain of things that happen here. So it's a fluent multi-step chain of calls or pipeline of calls. So let's take a look and see what each one of them does. The first thing that you do is you make yourself an RSocket requester builder. So you call the builder method. That starts things out so we end up with an object that can have fluent methods called on it. We then set the MIME type for the connection. And what we want to do here is we want to use the application concise binary object representation format, the CBOR protocol as it's known. So we set that up. That's going to enable the use of binary communication. The next thing we have to do is say what kind of binary communication we want to have. And we're going to use the Jackson CBOR encoder and decoder. So you can see we have this thing called RSocket strategies, and that's set to be the appropriate one down here. And so we make ourselves have the new Jackson encoder and decoder. We also add something else here, which is a simple authentication encoder. And that's used to do the authentication portion of the setup. That's a slight different type of strategy, but it deals with authentication. So we have to add that too. That's something that comes out of the box. The next thing that we do is we go ahead and set up the connection strategies. And the connection strategies can be done for various purposes. You can set up the keep alive interval for the client and the server to communicate, make sure they're still alive. You can set up interceptors. You can set up policies to handle what happens when the session resumes. You can set up acceptors. You can set up retry policies and so on and so forth. So we set up a retry policy here, a reconnect policy that says, if we can't get connected to the server for whatever reason or the connection is dropped, then try up to two times with a 2-second delay between retries. And then we also set up another thing, which is very interesting. This is the acceptor. So remember, the server is going to contact the client once the connection is initiated, telling the client, I am here, I've got your connection, I'm saying it's completed now. And it has to know how to talk back to the client. So the client's actually also a server. So to handle this in socket land, we have to set up a socket acceptor, which is this thing, on the client. Normally that's a server-side thing, but it's on the client. And to set up this acceptor, we create an acceptor, and this particular acceptor is going to have a connect response handler associated with it. And the connect response handler is the target of the message from the server back to the client during this handshake when we're setting up the connection. There are also methods that the client uses to connect with the server and authenticate itself. So we're going to set up the route to talk to the server. Remember, if you take a look at the connect mapping in the quotes connect controller, you'll see that it had this server connect as the path for the connect mapping. And this is the client saying, I want to talk to that particular endpoint when a connection is set up. We also set up the metadata. This is where we put the information about who we are, our username and password. Again, you wouldn't typically hard code passwords into code just to show you how to work it. And then we also put the MIME type indicating this is an authentication string. So that goes as metadata with this request. And then finally, we set up the data that goes with this connect request, which is just a random string that the client uses to identify itself to the server, a random UUID. The very final piece of the puzzle here is the client goes ahead and connects, or it creates a connection to the server at whatever the server host is on, which in this case is localhost, and whatever port the server is listening on, which is also defined in that constants file. So now we've defined the way in which we can communicate with the server, and that ends up being returned here as a mono to an RSocket requester. So let's talk about the client quotes proxy class. There is no equivalent to HTTP interface declarative clients or retrofit declarative clients for RSocket. So if you want to simplify the programming, you have to define your own proxy. And we define one because we don't want to have to write all that nasty code all over the place. So we define some methods that we're going to call. And these methods demonstrate each of the following 4 interaction models that are supported by RSocket: request response, channel, fire, forget, and request stream. So let's take a look at a couple examples. The first one we're going to look at is the way in which we auto-wire the requester socket, our RSocket requester, into the quotes proxy. So this is using that bean that we defined in the client beans class we just looked at. Here's the subscribe proxy method. This creates and returns a subscription that's going to be confirmed by the server. So this is a good example of request response. And as you can see here, we go ahead and take the quotes requester, and we are going to create metadata that wants to talk to the subscribe endpoint. And we create data, that indicates the UUID and the type. The type would be zippy or handy. So that's going to go into this message. We just made ourselves a message with metadata and data. And then we go ahead and we tell the RSocket mechanism in Spring to send out that request to the server and then get back a result, which will be the updated or the confirmed subscription. So that's what comes back to us here. And you can see how we use the various project reactor types like map and flat map in order to coordinate those interactions. And we also have this interesting feature that's part of Mono called cache. And what this says is turn this Mono into a hot source and cache the results. So anytime somebody comes along and asks for something that is for this particular subscription, return that result. Then the other method, proxy method we're going to look at real quick is the get all quotes method. And what that does is that goes ahead and uses a very cool mechanism called zip width. Zip width takes 2 monos. The first mono is the mono that's going to be the one that's connected to the client, to the server rather. And the other is the subscription request that we pass in. And it's going to take those 2 things, and when they both emit, it's going to then go ahead and forward, to this next call, which somehow I seem to have omitted. But basically, it'll call the quotes proxy get all quotes. And we're going to take a look at that call when we look at the code here in a second. And then the last piece of the puzzle on the client side is, at long last, we're actually doing backpressure, which is the whole point of this thing. And so there's a backpressure-aware subscriber implementation called a blocking subscriber that will be backpressure-aware and will also block because we want to be able to wait for the results to come back. And it uses the same subscriber subscription model that we covered earlier in the context of Project Reactor. So if you recall our discussion about backpressure and Project Reactor, when the client, which we call the requester, comes along and makes a request to the server, which we call the responder, it says how many items to send it before it needs to ask for the next chunk. So this avoids fast responders overwhelming the resources, the compute and buffering resources and so on, of slower requesters. And so we'll get a chance to see how that works in just a second. Okay, so that's the end of the overview of the client side of things.